Hello everyone, my name is Manpreet Singh. Today in this video, I'm going to talk about secrets. What are the challenges with secret management and a demonstration of a tool to solve these challenges. Now let's talk about what are secrets. Now secrets are anything that gives you access to a resource, and we are most familiar with the human to machine secrets such as passwords, multi-factor authentication smart cards sometimes that we use to access the internal resources, internal websites, FIDO tokens, and biometric authentication. And to give you an example, in our daily lives, we use our face biometric to unlock our phones. So in this case, we, as a human, using a secret, which is a biometric authentication, to unlock a machine, which is our phone, to access certain resources, which are actually inside our phone. But today, in this video, I'll be focusing on machine-to-machine secrets because in any organization, workloads are increasing and number of applications are growing, requiring secrets to communicate with each other. For example, one microservice talking to another microservices via API keys to access certain functions. Maybe an application using the static credentials like passwords to connect to the database to access the sensitive data or PI data that's stored in the databases. So all of these applications can use varieties of secrets to communicate with each other and to exchange the data with each other. And these secrets are not only limited to static secrets like password, they could be a dynamic secrets that are keep on changing, keep on rotating, and they could be SSH keys, API keys, and tokens like Joe token, which can be used by these applications or these microservices in CI/CD pipeline to actually exchange the data or to communicate with each other. So let's talk about the challenges we see with machine-to-machine secrets. As we see in an automated DevOps environment where a lot of secrets being used between machine to machine for communication, but it leads to secret sprawl and the likelihood of not being able to track all the secrets. And there's a statistics from Key Factor that says that 62% of organizations do not know how many secrets they have. And you have likely heard the stories of secrets leading to a breach or potential breach because they were found in the files of a GitHub repository or something similar like static configuration file. And the reason it happened because these organizations were not aware whether they were storing any kind of secrets or certificates in their environment. They didn't have that kind of visibility. And that actually led to these kind of breaches. So the risk of breach grows much higher when we talk about secret sprawl. And the solution to this problem is secret management. And again, secret management starts with two things. The first one is secret discovery to understand where are your secrets. And second is then managing the secret lifecycle from a single source, aka secret vault. So I have this particular problem statement and let's see how we can use these two methods, discovery and a secret vault to address my problem statement. The problem statement is that someone in the application team is using static credential in the application to access the S3 bucket content. However, the security team has no visibility as to what types of credentials are being used and where are those credentials stored. The second one is a security team wants to remove the static secrets from this environment and also cross-validate it once these secrets have been removed. And wants application team to use the short-lived dynamic credential to mitigate the secret misuse or secret breach. And the third is solve secret zero. So there should not be any secret lying inside the application code. Right. So these are three problem areas that we'll see how we can use the discovery and the secret management tool to address these three problem areas. Okay, so I have this application that's running on a remote server 65.1.228.72, and what this application is doing is basically trying to access the sensitive file from a bucket named mman-s3-secrets. and the DevOps team is actually using static credentials to access this particular bucket. However, security team is not aware as to what types of credentials are being used in this environment. So they want to scan this entire application server to identify the location if there's any type of credentials are being used, like static credentials, and the location of those secrets, and then take the appropriate actions accordingly to remediate those secrets in this environment. So yeah, so before I do that, let me just show you the behavior of this application. As I said, in this, as you can see, there's no static. You don't see any static credentials that have been configured in the application code. So it's using the static credential from a file, and those credentials are then used to authenticate to this bucket to access the contents that are stored in this this particular S3 bucket. Okay, so to discover the secrets in this application server, I'm going to use the Thales CipherTrust Manager solution. So let me just log into this platform. So this platform covers multiple use cases, as you can see on a landing page. That it covers different type of use cases around encryption and key management. However, today I'm going to talk about the discovery of the secrets and the secret management. So I'll click on data discovery and classification tile. So here I see a lot of tabs. So the first step we have to do is to configure our data store. So I'll go to data store and click on data store tab, and here I see I've already added my application server. So data store is basically a location where I want to run the scan, and here obviously for our demonstration I want to run the secret discovery for my application server, and I've already added it here. So I'll click on application server, click on connection tab, and here I see the private IP address of my application server, which is it is the same server that I'm trying to access via Visual Studio Code to run my code. But here I'm using the public IP address to connect to it. However, in my CipherTrust Manager's platform, I'm using the private IP address to communicate with my application server. Now, once this application server as a data store has been added, now I need to configure the scan. So I'll click on the scan tab. In the scan tab, I already see multiple scans have already been added, and these are for different scenarios that I was testing in my environment. But today we will be doing the scan for the secrets in the application server environment. So I have already added application server scan 1, and when I click on it, I'll go to the data store. So this is the data store I want to scan, which is my application server. Then I scroll down, then I click on the classification profile. Now in the classification profile, so this profile basically is an important step which actually tells the discovery engine that what type of secrets this discovery engine will actually try to scan or try to find in my application server environment. So I have already selected a inbuilt classification profile with the name of secrets. And if I go further into this profile to show you that what type of secrets we are going to scan in our application server by the discovery engine, I'll just go to the classification profile, click here, search for secrets. So I'll click on the info type. So yeah, so these are different types of secrets. This particular classification profile actually gives you the option to scan in any data store. So I'm going to, so it will be scanning the so in this classification profile, the discovery engine will basically scan for AES key, Artifactory token, AWS key ID, Azure storage key. I mean, there are different type of secrets that have already been added into this platform, into the pre-built classification profile. It can also scan the private keys that are stored in the application server, any SSH private key, any SSH public key that are stored uh, in the environment without any ownership, and also it can also scan for the triple desk keys and the other type of secrets. So yeah, I mean, this is a inbuilt secret classification profile that we have in the environment. However, customers have the options to create their own secrets info type as well, as we support custom info types as well. Okay, so I'll go back to my scan steps. So I'll click on the, so I'm going to run the scan on this application server. So I click on run now. So what it's going to do, it's going to command the discovery engine to scan for secrets as per the definition in the class information profile. So let's wait for this scan to complete, and once it's finished, then we will actually generate a report to find out what type of secrets that are actually stored in this environment. Okay, so the secret scan has been completed on my application server, and it took 1 minute 28 seconds to finish the scan. Now let's generate a report for the security team so that they have the visibility as to what types of secrets have been discovered in the application server. So I'll click on add report and I give the name of the report. I'll say application server report 1. I'll select aggregated. Next, I'll select my latest execution or the latest scan, which I've just done on my application server. And then I'll click on save. So what it's going to do, it's going to take the data, or basically consolidate the data that have been scanned by the discovery engine and generate a report out of it for the visibility to basically to provide the visibility to security team. So now let's wait for this report to process, and then we will take a look into it. Okay, so our report has been generated. So now let's take a look into it. So when I click on view, it show me the name of the scan that we have performed the execution on our application server on 9th of January 2024, which took 1 minute 28 seconds on our application server. And the information that this particular scan was trying to find was the secrets, and we were actually trying to find 23 different types of secrets on application server. And as part of this scan, uh, this discovery engine actually scanned for 61 data objects, 61 different location in this application server, and out of those 61 location, it has found one sensitive data objects. Or when I say one sensitive data object, basically there is one particular location where we have found a secret, and let's see what type of secrets that we have discovered. So I'll go to the next step. Yeah, so in data store we can see that this scan has actually found the AWS key ID, one sensitive data objects into this particular application server. And to find the location that where we have found this AWS key ID, I'll go to the data objects tab, and here I can see that the name of the data object is credentials file, and this credential file is basically located at this particular path where we have found this AWS key ID. Okay, so now the security team has the visibility that there have been some credentials stored in this particular application server at this particular location, and this is the name of the file, the name of the object where these sensitive secrets have been stored, and we can actually cross validate it. And to do that, I'm going to copy this path, go to my application server, go to this particular location, and try to open this file. And when I open this file, I see these static credentials that are actually configured into this particular file. And these credentials are actually being used by my application to access the contents from the bucket. So yeah, so this is how discovery engine allows the security teams to have the visibility as to what type of secrets are actually stored in the environment. Uh, And now when security team has identified the static credentials stored in the application environment, they want to remediate it. And as part of the remediation, they want DevOps people not to use the static credentials in the configuration file and start using number one dynamic credentials to access the S3 bucket contents, and number two to implement the zero secret approach in the application. And to do that, CipherTrust Manager has inbuilt secret management capability, which can allow DevOps people to start generating dynamic credentials and to implement the zero secret approach as per the recommendation from their security team. And obviously we will be doing some configuration into this environment so that we can actually implement that approach. Okay, so let's understand the environment first. We have this application server on the left hand side, and it's running in the AWS environment. And this is the same application server where we have run our discovery tool to identify the static secrets. And then we have a CipherTrust Vault, CipherTrust Secrets Management Solution, which will be used to generate the dynamic credentials and to implement the zero secret approach as suggested by the security team. And then we have our S3 bucket, which will be accessed by our application server or by our application to access the contents that are stored here. Now, to do that, as I said, we will be doing some configuration in our CipherTrust Secret Management solution, in this solution. So what we are going, as I said, we are going to implement zero secret approach. And to do that, we are going to use the AWS IAM role. So the way it's going to work that since application server is running in the AWS environment, it can use the AWS IAM role to authenticate to the CipherTrust Manager platform, where CipherTrust Manager will use AWS as a trusted identity provider to validate the request coming from the application server. And post successful validation, it will return a token, and then this token will be further used by application server to generate the dynamic credential from the CipherTrust secret management solution, and then use those dynamic credentials to connect with the S3 bucket. Okay, so let's see how we do it in our CipherTrust secret management solution. So I'll go back to my CipherTrust secret management solution where I've already configured a target. So this is the target which our CipherTrust secret management solution will use when it will be generating the dynamic credentials for the application to connect with the S3 bucket. And then we have the user and authentication method. As I said, we will be using the AWS IAM role to implement the zero secret approach. So I've already added this particular authentication method, and obviously this solution support varieties of authentication methods to authenticate to this platform, because this will be used as a centralized single source of a secret management solution in the enterprise environment. So it has to support different varieties of authentication methods, because there may be some application running in the Google environment, maybe in Azure environment. So it's maybe running on premise using LDAP or OIDC or SAML type of authentication. So this platform supports varieties of authentication method. So I'm using the AWS IAM because my application is running in the AWS environment. So I'll be using the AWS IAM role authentication, and this is the access ID that I'll be configuring in my application to authenticate to this platform, which in turn CipherTrust Manager will use AWS as a trusted identity source to validate my request and return me a token to further request for the dynamic credentials. So yeah, so this is about the AWS IAM roles, and then the third step is to actually configure a dynamic secret with the name of AWS S3. And if I go click on here, if you see that its target is basically the AWS credentials, right? And this is the same target that I've created here, right? So let's go back to my application code. So as I said, we will be using zero secret. So in the zero secret, first step is to authenticate to our CipherTrust secret management solution using IAM role. And to do that, I need to pass the access ID. And this is the access ID that we have actually got from our secret management solution. So it's the same access ID. Here you go, that I'm using. I'll go back here. So yep. So once this, as I said, once this authentication is successful, the CipherTrust Manager will actually return me a token, and then I will use, basically this application will now use this token to access this dynamic secret with the name of AWS S3. Now if I go back here, I already have this secret. As I said, I've already created a dynamic secret AWS S3 whose target is AWS. So what it means that as soon as this code runs, so it will use the token to again authenticate back to the CipherTrust secret management solution, and then CipherTrust secret management solution will use AWS S3 dynamic secret to generate the dynamic secrets for me, and then those dynamic secrets will be used to connect to my S3 bucket. Okay, so let's run this. But as I said, so our primary objective is to remove the static secret from this environment and only use the dynamic secret and implement the zero secret approach. So let's first remove the static secrets that we have actually identified as part of our discovery uh, uh, as part of our discovery exercise. And let's see what happens. So I'll go back here. So I'll open this credentials file. I'll remove this file from here. I'll save it. I've removed the static credentials from my environment, and I'm going to run this modified Java sample and see if I'm still able to access the contents. See. So as you can see, what's happening that it's using the AWS IAM role to first authenticate to the CipherTrust Manager platform, then it used the token to generate the dynamic credential, and then use these dynamic credentials to talk to the S3 bucket. And these dynamic credentials are only valid for 1 hour. However, you can also set the validity, but yeah, so that's how you actually access the contents of the S3 buckets using the CipherTrust secret management solution. And now, once we actually made these changes to our code, right, and we are no longer using the static credential, but the security team wants to reassure that we have done those changes in the environment. So what they can do, they can actually go back to the CipherTrust Manager solution. Here, go to the data discovery, go to scans, and again run the scan. Okay, so the scan has been finished. So let's generate a report and see if we find any credentials, any secrets in this application server post our changes into the application code. So application report server report 2. Save, click on generate. So let's complete it, and then we will take a look into this report. Okay, so the report has been generated, and let's review it. And when security team review this report, what they find that this time after the DevOps team have made those changes in their application team, there is no secret has been identified or discovered into this environment, which means that this tools allows the security team to cross-validate the changes that have been suggested and recommended by them to the respective business owners or to the respective DevOps teams. And yep, and as we go further, so if we go in the data subject, it is not showing any data object that contains the sensitive information. Okay, so this brings me to the end of my session, and this is where we have seen that how CipherTrust Manager allows security team and DevOps teams to work together to implement secure secret management capability from one single unified platform. Thank you very much for watching.